Good morning everyone. For today's video, I'm going to tackle about the grade 9 mathematics, the 6 trigonometric functions, the sine, cosine, tangent, secant, cosecant, and cotangent. So I am Rico Sasona, BSc Math 3A from Papalong College of Agriculture, Sciences, and Technology. So the objectives are, at the end of the lesson, the students will be able to determine the opposite, adjacent, and hypotenuse from a given right triangle. Second is to illustrate the 3 trigonometric functions, sine, cosine, and tangent. And the third one is to cite real-life equations involving concept of trigonometric functions, sine, cosine, and tangent. So here, as you can see, the trigonometric functions are sine, cosine, and tangent. And they are actually called the sin, cos, tan for short. So as what you can see in the right side, we have a right triangle. It is called a right triangle because there exists a 90-degree angle. And the hypotenuse can be seen in the opposite of the right triangle. So the right angle is in the bottom, then the slant line is the hypotenuse. And if there is a angle theta, this is called a theta. You can locate opposite by locating the opposite side of this angle theta. So here, this is the opposite side, and the last one is the adjacent, the remaining side. So we have a formula of the sin, cos, tan, where sine theta or sine x is equal to opposite over hypotenuse, and the cos is adjacent over hypotenuse, and the tan is opposite over adjacent. We need a way to remember all of these ratios. So the mnemonics or the acronyms should be SOHCAHTOA. SOHCAHTOA for the sine is equal to opposite over hypotenuse, cos is adjacent over hypotenuse, and the last one is tangent is equal to opposite over adjacent. So finding sine, cos, and tan. So just writing a ratio or decimal. So given the figure below, illustrate the sine, cosine, tangent of angle theta. So we have here the angle theta, and the value is 345. So the solution is here. We must first locate where is the hypotenuse, adjacent, and opposite. So as we locate the angle theta, we will mark the opposite side as opposite. Then there exists a 90-degree angle, then the opposite of that is the hypotenuse, and the remaining side is the adjacent. So we will write the sine, cos, tan formula where SOHCAHTOA. Then we will just put the value. So here in the sine, we will write opposite over hypotenuse, where the opposite has a value of 3 and the hypotenuse is equal to 5. So therefore, the sine theta is equal to 3 over 50. Right? So the next one is cosine, adjacent over hypotenuse. Adjacent value is 4. Then the hypotenuse is 5. So the answer is 4 over 5. So cos theta is equals to 4 over 5. The last one is the tangent theta. Tangent theta is opposite over adjacent. So we will just write adjacent, opposite is equals to 3, and the adjacent is equals to 4. So we have 3 over 4. You can write it in a decimal form also, if you want to be specific. So we have here the other example given the figure below. Illustrate the sine, cosine, and tangent of the angle theta. So we have here spotted the angle theta below, and the first step is we will locate where is the hypotenuse, opposite, and the adjacent for us to easy solve the problem. So this we can locate the opposite by locating the angle theta, and the opposite side is called opposite. Then the right angle here, the opposite is the hypotenuse, and the remaining one is the adjacent. So the opposite side has a value of 5, and the hypotenuse is 6, and the adjacent is 4. So to come up the value, we have to write the formula. So katawa, so sine theta is equals to opposite over hypotenuse, where the value is opposite has 5 and the hypotenuse is 6, so 5 over 6. And the cos theta is adjacent over hypotenuse, adjacent where the value is 4 over 6. So as we can see, 4 and 6 has a common denominator or common digit, right? So we can change it into the lowest term. So for 4 over 6, divide both number by 2 is equal to 2 over 3. So the cos theta is equal to 2 over 3. Then the tangent one is the opposite over adjacent. So the opposite side, the value is 5 and the adjacent is 4. So we have to write 5 over 4. Then as easy as that, see you on our next session for the discussion of the opposite of the sine cosecant, the cosecant, secant, and the cotangent. Thank you for listening. That will be all. Thank you.